Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 8, 2025, just yesterday. The standout result is a trajectory-aware reinforcement learning method for diffusion language models that delivers big wins, including a 6.1% relative accuracy gain over QN 2.57b instruct and 51.3% over Llama 3.18b instruct on math benchmarks. The paper is titled Revolutionizing Reinforcement Learning Framework for Diffusion Large Language Models, and the implications for model training are quite significant. Beyond the headline gains, the work introduces a diffusion-based value model for stability, a long chain of thought variant, and an open framework with accelerated key-value cache and inference engines. Alright. Figure 1 highlights two takeaways. The new reinforcement learning setup climbs faster and steadier on Math 500, and the TRA-do models post stronger benchmark scores than comparable autoregressive baselines. The left panel tracks training curves, which rise higher when the diffusion-based value model is included because it stabilizes updates. The right table lists accuracy on math and live code bench, showing consistent gains at 4 billion and 8 billion scales. So the table distills the headline comparison. The TRA-do models rank at the top on Math 500, AIME 2024, and Live Code Bench v2, which signals stronger reasoning and coding. Long chain of thought means the model deliberately writes extended intermediate steps before final answers. The shaded rows highlight TRA-do 8b thinking and instruct variants, while the 4b version still beats larger autoregressive baselines. The lower block lists QN 2.57b instruct and others for context, showing clear gaps. Alright. Figure 2 contrasts semi-autoregressive fine-tuning under full attention versus block attention. The figure shows that block attention trains in one pass over blocks, which keeps computation roughly proportional to sequence length because attention is limited within blocks. Full attention must slice the data into shorter sequences so it repeats forward passes and pays extra cost. The left panel illustrates slicing, while the right heat map highlights which tokens attend within each block. So the table summarizes head-to-head results, showing that the TRA-do models lead most math and coding benchmarks under both static and dynamic sampling. Dynamic sampling means the model adapts how many steps it takes during generation, which can boost accuracy and speed. The 8 billion TRA-do instruct tops Math 500 and stays strong on Live Code Bench v2, while the long chain of thought variant pushes scores even higher. The 4 billion TRA-do still beats larger autoregressive baselines, which underscores efficiency. Okay, two takeaways stand out. Aligning reinforcement learning with the actual decoding trajectory boosts both stability and accuracy, and the diffusion-based value model keeps updates steady while enabling long chain of thought reasoning. The broader implication is practical. Smaller diffusion models can beat larger autoregressive baselines and sample faster. Thanks for listening. I am Alex, signing off.